So one of the key tools that is used for developing the schedule is the critical path method. Let us try to understand what is critical path. A critical path is a path where the least amount of float and slack time is available. If you can remember, under sequence of activities process, we discuss and define what is a float and what is a slack time. So critical path we usually take as critical path where the float is 0, where there is specifically there is minimum float or there is no float at all. Under critical path method, let's discuss this example. Under sequencing activities, we already discussed the notation of representing a network diagram. This notation, can you remember, where the early start time and the early finish time, the latest start duration, the latest finish time is indicated, and the duration is indicated in this box, and the total float is indicated in this box. So with that revision, let's look at this network diagram. So from the start of the project, there is an activity A, and after activity A, there are two activities that can start parallelly, activity B and activity C. And activity D is waiting for the output of activity B and activity C to commence the activity D. In this example, please note that the example has been developed using calendar days. So, to understand the diagram, the activity A has a duration of 5 days, activity B has a duration of 5 days, activity C has a duration of 10 days, activity D has a duration of 15 days. So if the project starts from the day 1, activity A will consume 5 days, and including the day 1, it will supposed to end, the earliest finished day will be on day 5. Please note again, this example is based on calendar days. So then activity B is scheduled to start on the next day, on day 6, and activity B will has a duration of 5 days, and including the 6th day, calculating 5 days, the activity B will finish at early finish time of 10 days. Same goes here. Activity A finishes at the end of the 5th day. Activity C can commence on 6th day. Activity C needs 10 days to complete, and activity C will, at the earliest finish date, will be the day 15th, where the activity C will end. And if you take activity D, activity D waits for the output of activity B and activity C. So the activity B, the earliest finish date is day number 10. Activity C, the earliest finish date is day number 15. But the earliest start date for activity D, since it needs the output of C for the process of the D activity, the earliest start date is the day 16 and not day 10, because D has to wait until C finishes. So the earliest start date is day number 16. Activity D will have a duration of 15 days, and activity D will end on the 30th day. So this is the calculation method for the earliest start date and the earliest finish date. On the critical path method, we go on a backward calculation to find out the float. So the earliest finish date of the project is 30, then we can include it as the latest finish date here, and activity D needs 15 days to complete. So calculating backwards, activity D, the latest start date will be 16 days. And if you take activity C, since this is a calendar date example, the previous date will be activity, the latest finished date of activity C will be the 15th. It needs 10 days to complete activity C. Calculating backwards, the latest start date will be day number 6. Same goes here. Activity B, the latest finish date will be 15th, 5 days for the completion, and then the latest start date for activity B will be 11 days, the day number 11. If you take activity A, B and C depends on the output of activity A. So the latest start date of activity B is 11 days, and the latest start date for activity C is 6 days. In that way, since C is depending on A's output, and the latest start date the activity C can commence is the day number 6, therefore the latest finish date of activity A should be day number 5. So activity A must finish by day number 5 in order to C to begin its latest start date. The latest start date of B is 11, and even though activity A ends in day number 5, it can still wait until day number 11 to start activity B. If you can remember, under sequencing activities, we explained the float is calculated by reducing the difference between early start date and the late start date, or the difference between early finish date and the late finish date. Under that, the float is calculated with the difference between early start date and the late start date, early finish date and the late finish date. So in here, the float is 0 because 16 minus 16 is 0. The float is 5 days, 6 minus 11 is 5 days. The float is 0 again, 6 minus 6 is 0. And the float here is 0, 1 minus 1 is 0. So under this example, the critical path would be where the float is 0. In other words, A, C, D. The highlighted arrows will signify the critical path of this project. Hope you understood that example.